everybody, this is 1.0b lesson, and we're looking at 10 by 10 grids and converting between fractions, decimals, percents. Okay, so we're going to write the equivalent values for the following parts of a candy bar. Okay, the bar on the left is divided into two equal parts. So if we're looking at one part, that would be 1 part of 2, and that's going to be 0.5 and 50%. If we're looking at 2 parts, that's 2 parts of 2, which is 1.0, which is 100%. This candy bar is broken up into thirds. So if we're looking at 1 part, we're looking at 1/3. As a decimal, that's 0.3 repeating bar, and as a percent, remember, we scooch the decimal over 2 places because we multiply by 100 to convert a decimal to a percent. Okay, 2 parts of 3 would be 0.6 repeating. Okay, this guy, we've got 4 pieces. 1 part of 4 would be 0.25. As a percent, 25%. 2 parts of 4. Okay, think about that, reduces to a half, doesn't it? Okay, so 0.5, 50%. 3 parts of 4 is 0.75 or 75%. Alrighty, 5 parts. 1 part of 5 is 20%. Is 0.2, which is 20%. 3 parts of 5 is going to be 0.6 or 60%. All right, this guy right here, how many parts is this? 1, 2, 3, 4, 5, 6 parts. 1 part of 6. Okay, now here's where I'm using a calculator because these get a little ugly. Okay, now if I multiply by 100 on this, do you see that's going to be 16.6 repeating bar percent? Okay, this is an important one to understand. If you understand this one, all the other ones should be easy peasy. Okay, 2 parts of 6, that reduces to 1/3. We did 1/3 a couple problems ago. 1/3 is 0.3 repeating bar, 33.3 repeating bar percent. 3 parts of 6 is 0.5, 50%. All right, last one down here. 1, 2, 3, 4, 5, 6, 7, 8 parts, 2 parts of 8. Well, that reduces to 1/4, 0.25, 25%. 7 parts of 8, that one I don't have in my head. If I put that in a calculator, it's 0.875. Okay, if we take 0.875 and multiply that by 100, 87.5% is what that would be. Okay, so from this page, you should be able to convert from fractions to decimals to percents. Okay, all right. To the left is a 10 by 10 grid. Why do you think it's called a 10 by 10 grid? How about the length and the width are 10 units? The length and the width are each 10 units. How could you use the 10 by 10 grid to show a fraction 6/100ths? Okay, in this grid, you need to color in 6 boxes out of the 100. So it doesn't matter which ones you do. 1, 2, 3, 4, 5, 6. I'm going to color in these guys right here. Okay, so shade in 6. Shade in 6 of the 100 boxes. Okay, and I guess I went ahead here on number 3. I already shaded that. Okay, and your shading could be different than mine. Some people would shade this way. Okay, I wouldn't shade random 6 boxes. I mean, you could, but it's hard, you'd have to count them, okay? All right, what fraction is shown in this 10 by 10 grid? Explain. All right, if I count up, this is 10, 20, 36 boxes. This is 36 hundredths, or that reduces to 9/25ths, okay? But 36 hundredths, it's easy just to see, there are 36 of 100 boxes shaded. Okay, what is the decimal equivalent? Okay, if you look at 36 hundredths, the way that you write 36 hundredths would be that. Okay, if you don't understand that that's 36 hundredths, then perhaps you'd take this 25 and divide it into the 9. 9 divided by 25. Okay, 25 goes into 90 3 times, that's 75. 36 goes into 156 times with no remainder, okay? What fraction is shown in this 10 by 10 grid? So this is 20 boxes out of 100. If you want to reduce it to 1/5, go for it. You don't have to though. A decimal equivalent, again, this 21 hundredths, isn't that 21 hundredths? Isn't this the same 2/10ths? Okay. All right, now we're going to go the other way. Given the number, we need to shade in 27 hundredths. 27 hundredths. So here's 10, here's 20, and then here's 7. There's 27 hundredths. This guy is 4/10ths. Well, 4/10ths would be the same as 40 hundredths. So I want 1, 2, 3. I need all of those shaded in. And again, just shade in 40. Doesn't matter if you went that way or that way, okay? All right, this guy's tricky. This number is 125 thousandths, and we need to think about what that would be as hundredths, because this is a box of 100. This would be 12.5. Okay, if we scooched over a decimal to the left and scooched over a decimal to the left. So here's 10, here's 12, and then I need half of this 13th box shaded. Okay, write the fraction represented in each model above. Well, I guess I already did that right above them, but I'll go ahead and rewrite them here. So this is 27 hundredths. This was 4/10ths, which is 2/5ths. And this was 125 thousandths, which reduces to 1/8. Okay, you would never, as a simplified fraction, leave a decimal inside of your fraction. You would never do that. So have your 125 thousandths, and then if you want to reduce that, go for it. Okay. All right. Last page. Shade the fractional part of each grid. Okay, 1/4. 1/4, again, this is 100. So if we want to think of that as 100, do you understand that that would be 25 hundredths? Okay, so this would be 0.25, and this is 25%. There are lots of ways we can shade 25 hundredths. So I just shaded 25 boxes. You can see that that's a quarter of this entire picture. Okay, 1/10. That would be 10 hundredths. There are 10 boxes shaded. That would be, you could either do that or you could do that. Doesn't matter. 10%. Okay, 1/5. That would need to be 20 hundredths. Let me go this way this time. There's 10, there's 20. That would be 0.2 or 0.20. Same thing, 20%. Okay, now for part D. Scooch that up. 1/100th. Well, there's my 1 out of 100. Now that is going to be 1/100th or 1%. Okay, this one is tricky. This one is tricky. Okay, if I want the 16 to be 100, okay, I'm gonna go ahead and a couple ways I could do this. I could think about how can I convert 16 into 100. Okay, and I could play with a calculator for a while. Or let me see if I divide 16 into 1. Okay, so 16 does not go into 10. Okay, it goes into 100. Let me think. 6 times? 6. Yes. And then 16 goes into 40 2 times. And that's even with no remainder. Okay. So here's the scoop. There's our decimal answer right here. That's ugly. And then our percent, we're going to multiply by 100, so that's 6.25%. Okay, well, 6.25 is exactly what we're going to be shading inside here. Because remember, a percent is really what it is over 100. Okay, so 6, 1, 2, 3, 4, 5, 6, and just a smidge of that 7th square. Okay, 1/3, 1/3. Okay, I know that 1/3 is 0.3 repeating. If I didn't know that, I would do this. Okay, so this would be 33.3 repeating bar percent. So I'm going to be shading in 33 and 1/3 of a 34th square. So here's 10, here's 20, here's 30, 30, and then I've got 1, 2, 3, and 1/3 of the next square. All right, so that's 10 by 10 grids going backwards and forwards. Given fractions, shade, given shading, give a fraction, okay? All right, use long division to show how you can convert each fraction to a decimal, then a percent. All right, so 3/10. The way that you say that is 3 divided by 10. Okay, 10 doesn't go into 3, but it goes into 33 times. Okay, so 0.3 is the decimal equivalent. Uh-oh, get that out of there. 0.3 is the decimal equivalent, and 30% is the percent. 2/5, 2 divided by 5. 5 goes into 20 4 times. So 0.4 is the decimal equivalent. 40% is the percent. All right, 3/8. I feel like I've done 3/8 already, but we'll go ahead and do it again in case I haven't. 3 divided by 8. 8 into 30 goes 3 times. 24, 6. Bring down the 0. 8 into 60. 7 times. 56. 40. So 0.375 and then 37.5%. Okay, now here's the deal. Sometimes kids get the 8 and the 3 switched around. If I switched around the 8 and the 3, wouldn't my answer be bigger than 1 whole? Is 3/8 bigger than 1 whole? No. Same with over here. If I switched around the 2 and the 5, wouldn't I have a number bigger than 1 whole here? Is 2/5 bigger than a whole? No. Okay. Same with this. 2 divided by 9. That is this way. Okay, 9 goes into 20 2 times. 9 goes into 20 2 times. So we're going to get 0.2 repeating bar. Okay, now if we multiply that by 100, we'd have 22.2 repeating bar percent. Okay, let me circle these guys so they don't get lost in the division problem above it. Okay. All right. That was 1.0b. Thanks, guys.